Okay, so today we're going to start taking a look at the Chapter 7 review. So the first ones we're going to look at are some of these verifying. And verifying is where we rewrite everything in terms of sine and cosine. So 2 cosine of x times tangent is sine over cosine. And cosecant is 1 over the sine of x. So that equals 2. That cosines reduce out, sines reduce out. 2 times 1 is 2, so 2 equals 2. The second one here, we have the secant, so that's 1 over the cosine of x, times cotangent, cosine of x, over the sine of x. And whoops, this is supposed to be, my bad, the cosecant of x. So this equals 1 over the sine of x. So we can see the cosines reduce out, and we have 1 over the sine of x equals 1 over the sine of x. So this third one here, let's see, tan squared. So that would be sine squared of x over cosine of x, cosine squared of x, times the cosine of x. 2 times 1 over the cosine of x equals 1/2 sine squared of x. So first thing I noticed, this cosine. So we'd have sine squared of x over the cosine of x divided by 2 over the cosine of x equals 1 over 1/2 sine squared of x. So we're dividing fractions. So we have sine squared of x over the cosine of x times the cosine of x over 2. So the cosines. So sine squared of x over 2. Well, that's the same as 1/2 sine squared of x. So we're done. So these next ones here, where we are asked to do some double angle stuff. So some of you guys I know skipped this. Some of you guys did do this lesson. So some of you guys can fast forward through these next problems. Others of you will be like, oh, okay, got this. So let's see here. Well, so let's see, it's terminal side in quadrant 2. So we have a triangle. 4 over 5, and so this has to be 3. The sine of 2 theta, so that's 2 sine of theta cosine of theta. So that's 2 our sine times 3/5, our cosine times -4/5. So we multiply across, so that would be -24/25. The cos of 2 theta, so that's cos squared minus sine squared. So cos squared, so -4/5 squared minus sine squared. So we have 16/25 minus 9/25. So that equals 7/25. And then tangent, we know that's the sine over the cosine of 2 theta. Sorry that this is so messy. Equals, and what was our sine? So -24/25 over 7/25. So that would be -24/7. This next one here, so it's in quadrant 3, so we'll draw a picture of this. Down here, sine, so -2/3, opposite over hypotenuse, so we have x squared plus -2 squared equals 3 squared. So x squared plus 4 equals 9. So that's going to be x squared equals 5, so the square root of 5, so -square root of 5. And then we have the sine of 2 theta again. So we got 2 sine of theta cosine of theta. So 2 times negative 2/3 times our cosine, the square root of 5 over 3. So this would be negative 4 times the square root of 5 over 9. The cosine of 2 theta, so that was cos squared minus sine squared. So cosine, square root of 5 over 9 squared. Not 9, my bad, that should be 3 squared, and that's a negative plus negative 3. I'm having trouble reading these here. Negative 2 over 3 squared. So we have 5/9 plus 4/9. So that would equal 1. Alright, and then the tangent, something seems off about that. I may need to think about this one for a second. It's supposed to be a minus. I didn't think it would be 1. That seems. So if we go back here, this is minus. So that's 1/9. So tangent, again, that's sine over the cosine. We have negative 4 square root of 5 over 9 divided by 1 over 9. So that would be negative 4 square root of 5. This was supposed to be negative, which would make this positive, which would make this one positive there. Sorry about that. All right, so these next couple everybody did. So we're solving. So to solve this one, we add 1. So the 2, the sine of x, equals 1. Divide by 2. So we're looking for where does the sine of x equal 1/2. Well, we know sine is our y. So y is positive in these top 2 quadrants, which makes these angles 30 degrees. So our actual angles are 30 degrees, which we know is pi over 6. And in that quadrant, it would be 150, which is 5 times 30. So we have 5 pi over 6. So the second one, it's already solved for the cosine, and cosine is negative, and cosine is our x. So x is negative in these quadrants. So we have negative root 2 over 2. Well, we know those are 45s. So 45, so this would be 135, which is 3 times 45. So that's 3 pi over 4s. This would be, let's see, 180, 225, which is 5 times 45. So we have 5 pi over 4. This next one, the tangent of x. So if we solve for that, we have the tangent of x equals negative root 3. So this is one where we have to figure out, is it a 30, 60, 90? So let's play around with this. If this is 30, we'd have 1/2 root 3 over 2. So opposite over adjacent would be 1 over root 3. So it has to be 60-degree reference. But we want it to be negative. So in this quadrant, we have root 3 over 2, negative half. That would give us a negative. As well in this one, because if this is 60, we have root 3 over 2, negative, and half. So let's see, so that's 120 degrees and 300 degrees. So 2 times 60, so we have 2 pi over 3s. And 5 times 60, so we have 5 pi over 3s. And this last one, the sine of x equals 1. So if we add 1, sine of x equals 1. So this is, where is our y value 1? Well, that's right up here, so that's at pi over 2. So now we have some more solving here. So if we solve this next one, minus 3 minus 3, tan of x equals negative 3. So if we divide by 3, that would mean the tangent of x equals -1. And let's see, so that has to be 45s, but they have to be negative. So that must be these quadrants here. So we have 315 and 135. So we got 7 pi over 4 and 3 pi over 4. The next one gets a little trickier because we got a quadratic. So we have to use that Pythagorean identity to replace this. So we know that that is 1 minus sine squared of x plus 3 sine of x. And I'm going to set this equal to 0 since it's a quadratic. So we have 2 minus 2 sine squared of x plus 3 sine of x minus 3 equals 0. Combine like terms, so -2 sine squared of x plus 3 sine of x minus 1 equals 0. If we were to do the quadratic formula on this, we have the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So we have -3 plus or minus the square root of 9 minus 8, 1 over -4. So -3 plus 1 over -4. So -2 over -4, positive 1/2. -3 minus 1 over -4. So -4 over 4 is 1. And we're talking, this was the sine. So we could make our graphs again. So here's our sine where it's positive half. Sine is 1 right here. So those would be 30-degree reference angles. So we have 30 degrees, which equals pi over 6. 90 degrees, which we know is pi over 2. And 150, so 5 30s, so 5 pi over 6. So the next one we look at is another quadratic. So we can do the quadratic formula. The opposite of b plus or minus the square root b squared, so 49 minus 4ac all over 2a. b squared minus 4ac. So let's see, 49, 8, that would be 32. Is that turning out to be 17 there? Something doesn't seem right. B squared minus 4ac, so 7 squared minus 4 times 2 times 4. So 49, well, that's a minus, so plus, that's what it is. 16 times 2 is 32, so we have 81. So 7 plus or minus the square root of 81 over 4. So we have 7 plus 9 over 4. Well, that's 4, so we don't need to worry about that one. 7 minus 9 over 4. -2 over 4 is -1/2. So our cosine, our x value is -1/2. So we have -1/2 here. So that makes these 60. So 120, 2 times 60, so 2 pi over 3. This would be 240, 4 times 60, so 4 pi over 3. And I think we end with a nice and easy one. 2 sine of x equals 1. So we have the sine of x equals 1/2. Sine is our y value. So 1/2 and 1/2 makes these 30-degree reference. So 30 degrees is pi over 6. This would be 150, which would be 5 30s, or 5 pi over 6.